we use radian descriptions when we're talking about things you need to know without a calculator. So on your next test, whether it's a little quiz or anything else, I would be more likely to ask you to tell me the tangent of pi over 4 than the tangent of 45 degrees. Okay? Now, I'll show you two quick ways where this makes formulas a lot easier. Arc length and sector area. Arc length and sector area. Okay, arc length. Let's see if I can draw a circle. I had a colleague at my last school could draw perfect circles freehand all day. Used to have contests with kids. It was really kind of freakish.
They weren't exactly perfect, though.
Yeah, they looked perfect looking circles. You're right, Cody. I did not actually measure their eccentricity. And
in Las Vegas, they have a competition every year, and if you enter once, you can keep on going it.
For drawing circles?
Yeah.
Are you serious? You're not making this up?
No, I'm not.
All right.
You should not do this, Mr. Belvo.
All right. No, I should not do this in my drawings, but I should take my old friend Roberto out there and have him do it.
Well, it's also speed drawing, so you have to do it like, and then if it's perfect, then you probably allow one.
Okay, on this circle, which is probably will look better in anybody's notes but mine, just to clarify what I'm about to speak about, we have a spurt. Rewind, take two. We have a circle, okay? A circle has a radius. That's a radical idea. If the radius sweeps out an area by moving, okay, or we have two radii, you'll create an area in between them. It'll be like a slice of pie. Pi, bless you, not the Greek letter pi, representing 3.14, but like an actual slice of pizza pie.
We get it.
Okay, good. And then you have an arc length, which is a one-dimensional measure along the circumference. And what happens is, I'm going to double check these since I've gotten everything else wrong today, as I've said it. I want to make sure I present them to you correctly. I know, it's much less fun. Okay, here it is. I buried it. Now, finding these things should be something you did at some point in geometry. Is that correct?
Yeah.
Okay. If you're using radian measure, it's actually this easy. Okay? The arc length, which is usually called S, is simply the length of the radius times theta, as long as theta's in radians. Okay? All you have to do to find this arc length is take the length of the radius and multiply it by theta as long as you have theta in radians. Because what you're doing is you're representing this arc length as a proportion of the circumference. And since the formula for circumference has 2 pi in it, that only works if you are actually in radians. So, for example, a circle has a radius of 5. Circle has a radius of 5. Okay? What is the arc length if theta equals 45 degrees? If you did this in geometry, then what you did was you figured 45 degrees was 1/8 of the way around the circle. You found the whole circumference, you divided it by 8. Maybe you set up a proportion. I don't know. If you didn't do it, however, the easiest way to do it now is you say the arc length S is the radius times theta. The radius is 5. You switch 45 degrees to radians. What is that in radians?
Pi over 4.
Pi over 4. We got it on the board over there. And the distance is actually 5 pi divided by 4 units. Whatever that is.
Would it be 5 pi times 20 units?
Pardon?
Would it be divided by 20?
Why?
Because you got it in parentheses.
No, we're not distributing with this. This is just, I had in parentheses just to represent multiplications, but this is still 5 over 1 times times pi over 4. Multiply the numerators, multiply the denominators.
Okay.
Good question. Yeah. If it's exponents, what you just said would be true, or if there was addition or subtraction. Like this is multiplication still. Okay, there's a similar area formula. The area simply equals 1/2, make sure I write this correctly, r squared times theta. Now, if you did this in geometry, you'd find the area of the whole circle. And then you'd have to set up a proportion, figure out just the area of that one slice. Now, if we do an example and I say a circle has radius 8 and theta equals, I'm going to say 60 degrees, okay, what is the area of the slice? I'm thinking in terms of pizza. Okay, if you did this in geometry, you figured 60 degrees was 1/6 of 360 degrees. You found the area of the whole circle, you divided by 6. Radians takes care of that for you. It already is your distance around 1/6 of the circle. So you say A equals 1/2 the radius of 8, you put in there, you put in for the radius, put 8 in for the radius and square it. What is 60 degrees in radians? It's right up there, take a look. Pi divided by 3. So it gets a little ugly here, but this becomes 1/2 times 64 times pi over 3. Half of 64 is 32. So I could just leave my answer as 32 pi over 3 if I did not have a calculator. If I had a calculator, I would get some sort of decimal answer, somewhere around 33 or 34 probably. So these two formulas simplify life nicely. Last thing I'm going to talk about today, before theta is like x for angles. Theta is just like x for angles. It's the Greek letter they choose to use for angles you don't know the measure of, which can also change. Well, we'll get to that later.
They use x as the Greek number x, or just x is the top of x?
Pardon?
You know x is like 10?
Yeah.
Is that what it's supposed to be, or is it just like alphabetically x?
Oh, good call. It says lowercase t, and I'm not really sure in Greek. I'm not really sure how it got chosen. They made a decision with Latin letters to make x, y, and z variables, and like a, b, c unknown constants. That was Rene Descartes who came up with that. I'm not sure who decided to use theta for angles and why it was chosen. There's no good pattern to it.
Did Rene Descartes come up with that?
Can I teach physics next year? Thank you.